Hi Geometry, this is our last video on the concepts from Chapter 7. This is on trigonometry. After you finish this video and you go through your review sheet, please email me any questions and then I will supplement that with a video answering everybody's questions, either on your review sheet or other homework problems. So be specific as to what those problems were. So if you feel comfortable with this and you want to pause and go through and try them on your own, go for it. But I want to go through the calculator steps as well, and remember everybody's calculator is different, so you should know by now if your calculator is the type that you put in the angle and then push sine or cosine, or the other way around. So make sure from the beginning you remember your ratios. Sine, cosine, and tangent are functions given an angle in a right triangle of two sides, a ratio of two sides of that right triangle. So if we look at these first two right triangles, notice where your opposite, adjacent, and hypotenuse are. Well, your hypotenuse is always in the same place, but where your opposite and adjacent sides are totally depends on the angle that you're going to use. So always locate the angle first. Here our angle is x degrees, so our opposite side would of course be over here. Our adjacent side is next to the angle x, and our hypotenuse, of course, is always across the right angle. So if you have numbers in here, for instance, this is a 3, 4, 5 right triangle, and they ask you for what is the sine of x as the ratio, sine is opposite over hypotenuse, so you just say 3 over 5. The cosine would be 4 over 5, adjacent over hypotenuse, and the tangent would be opposite over adjacent, 3 over 4. If the question is just what is the ratio, you are done once you give me the ratio. You should not have to touch your calculator on that problem. Now notice here, x is in this top corner. Our opposite side would be there, so always locate the angle first, find the opposite side. The hypotenuse is, of course, from the right angle, and the adjacent side would be with the remaining side formed by the angle x. Okay, so there are three basic types of problems that you're going to have to do on your calculator and be familiar with. The first one here, we're given an angle. We want to think about which sides that we are given and what we're looking for. We're looking for x. And so the 4 here looks to be the opposite side of the angle that we're given. The x is obviously the hypotenuse. And so if I look which function is opposite over hypotenuse, that is sine. So don't just start pushing buttons on your calculator. Write out the function, the sine of the angle. The angle is 21. Always have the angle next to the function. Is equal to the opposite side, which is 4, over the hypotenuse, which is x. All right, we are trying to solve for x, and we know if x is in the denominator, we can't just throw that 4 over to the other side. We need to get x off of the denominator. So we're going to multiply both sides by x. So on this side, x divided by x is 1, so we just have 4. Here, so we have x plus x times 21, sine of 21, equals 4. Now the sine of 21 is just a number, and it's connected to x with multiplication. So we're just going to divide it. The opposite operation, divide it to the other side. So x equals 4 divided by the sine of 21. Now I'm putting parentheses there because that's probably what your calculator is going to ask for. So on my calculator, I'm going to push the sine. Sine is often a second button, but not always. Excuse me, that's not what I want to do. I want to push 4 divided by the sine of 21. And that comes out to be 11.16. And pay attention to what you're asked to round it to. Here I'm rounding it to the hundredths. Okay, remember if you want to pause this video, I think it'd be a good idea to write down these two problems and try them first on your own. But if you need a little refresher, let's go. Okay, the second kind, this is, I know it's hard to see, but that's a 46-degree angle. And so first find your angle and find the two sides and see how they're related. To the 46-degree, this would be our adjacent side. This would be the hypotenuse. So we think, okay, which one's adjacent over hypotenuse? And there we go. It's the cosine. So write down the function. There, so we don't get confused. The cosine of the angle, 46, make sure the angle's next to the function, equals the adjacent, which is x, over the hypotenuse, which is 7. So this algebra is a little bit easier. 7's right there on the bottom with division, so we need to just multiply it to the other side. Multiply both sides by 7. 7 times the cosine of 46 would equal x, and then we put it in our calculator. 7 times the cosine of 46. And it looks like we get 4.86. 4.86 rounded to the nearest hundredth. And that's the length of that side. Now we could use Pythagorean theorem to find the third side if we wanted to, or use sine equals opposite over hypotenuse. Okay, last type is and when we're looking for the angle. And when we are looking for the angle, that's when we want to use our inverse sine, cosine, or tangent, or inverse operation. So still, find the angle, it's x. Let's decide what these are. This is the opposite side. This is the adjacent side. So opposite over adjacent we know is tangent. So the tangent of the angle is x, equals the opposite, which is 6, over the adjacent, which is 5. Okay, the angle is not given to us this time. So in order to get the tangent over to the other side, to get rid of this and just be able to solve for x, we do not divide by the tangent. The tangent is a function. It is tied with that x. We need to do the opposite of taking the tangent of an angle, which is the inverse tangent. X equals the inverse tangent of 6 over 5. This is not an exponent to the -1. That just means the opposite of tangent, the inverse tangent, giving you an angle instead of a ratio. So to put that in my calculator, I'm going to push second tangent, inverse tangent, make sure it gives you that -1, of 6 divided by 5. Make sure you put your parentheses in. And that's 50.19. or 50.19 degrees. Now, if you're not getting these answers, make sure you come in and clear that up in case you're having calculator problems. Okay, so that's the 3 basic kinds of trig problems. You will also have the kind where you have to draw the triangle first with the word problem, so make sure you're practicing those. On this video, I also want to quickly go over a couple of more challenging problems where we pull it all together using triples, 30, 60, 90s, and 45, 45s. So I didn't put any trig in this, but of course that would be possible as well. And a lot of times on a 30, 60, 90, or 45, 45, you could just as easily have used trigonometry. So when we look at a problem like this, we have all these right triangles going on. The only angle we're given down here is the 30, other than the right angles. But of course we know these angles are 45 because we have an isosceles right triangle. So where do we start? Well, we start wherever we have the length of a side of a triangle, and we do over here. Look for a triple. This is a 7, 24, 25 exactly. So this length would be 25. The directions on this problem would be to find the length of all the sides. Now this is a rectangle. And since it's a rectangle, we know that the opposite sides will be equal. So this is over here 24, and this will be 7. Pay attention. You will see that's the same figure on your test. If this is 7, that's of course 7. And look at one triangle at a time. Now we're in this new triangle. If you get confused, just draw the one triangle that you're in separately. This is a 45, 45 right triangle with 7 and 7. So what's the hypotenuse? Exactly, 7 root 2. 7, 7, 7 root 2. So that belongs there. So now our last triangle is a 30, 60, 90. We have our x side across from the 30 is 7. Again, if you get confused, draw out just the triangle that you're working with. That's a 30 degree. We have 7. And write in your formula if you need to. That's x. Hypotenuse is 2x. Side across from 60 is x root 3. So if x is 7, the side across from 60 will be 7 root 3. Hypotenuse will be 2 times 7, or 14. So where do those belong? There's the 14, the hypotenuse, and there is the 7 root 3. So we found all the lengths of those sides. Just take one triangle at a time. Okay, next one, number 2 here. Looks like we got a 30, 60, 90. I know that I didn't draw that very well because it looks like this is the longer leg, but the shorter leg is always across from the 30. And here we have a 45, 45. So where do we start? Always start where we're given a side. So on a 30, 60, 90, write in our formula. The hypotenuse is 2x. Across from the 30 is my x. And across from the 60 is my x root 3. So if 2x is 12, this side would of course be 6. And x root 3 would be 6 root 3. Okay, well, now we've got a new triangle here to look at, a 45, 45, where our formula is x root 2. And oh no, now we're confused. How can this be x and x root 2 at the same time? Well, remember, only think about the triangle that you're working on. If you want to draw that 45, 45 by itself, then write in the formula just for it. This is 6. And so that's equal to x root 2 now in this triangle. We know how to solve that. The shortcut is to divide by root 2 and rationalize. So we divide by root 2. X equals 6 over root 2. We rationalize. And we get 6 root 2 over 2 equals 3 root 2. Let me simplify these two here. So 3 root 2, what have we found? We have found x, and x are the equal legs in that isosceles right triangle. So make sure you pay attention to what you found and write it in. Okay, the last one, 3 triangles. We have one right triangle here. I should put the right angle there. Looks like we got an isosceles triangle here, right? And here it looks like we have a 30, 60, 90. So where do we start? We start with the sides that we know. This is looking triple light. Yep, that would definitely be an 8, 15, 17, so I can find that 8. These two are equal sides, so this must be 8. So I've got this isosceles right triangle here with 8. 8, what's on the hypotenuse? Exactly, 8 root 2. So this side is 8 root 2. Well, now that can be confusing because now I've got a 30, 60, 90. Think about just the triangle you are in. Write in your formula. X, and we found that was 8 root 2. The hypotenuse is 2x. Across from the 60 is x root 3. So if x root 2 is 8 root 2, how do I find x root 3? X is 8 root 2 times root 3. So this side must be 8 root 6. Okay, so if x is 8 root 2 and I want 2 times x, I'm trying to find 2 times 8 root 2, which is 16 root 2 for this hypotenuse. So where does that go? That's this side, 16 root 2. This side was 8 root 6. So now I've found every side. Those are the little more challenging problems when we pull them all together. Try them on your review sheet and email me if you need me to work some out for you.